Hello, fellow audio adventurers and sonic explorers. Ernis here, your guide through the wild frontiers of sound research. Today, we're diving headfirst into a paper that's making waves, literally. In the world of audio generation, WaveNet, a generative model for raw audio. Now, you might be thinking, raw audio? That sounds complicated. And you're not entirely wrong. But fear not, because we're going to break it down with the clarity of Feynman, the cosmic perspective of Sagan, and just a tiny dash of Rick's irreverence. So, what's the big idea? Well, imagine you're trying to build the ultimate musical instrument. Instead of carefully crafting each component, you simply give it the ability to learn how music works, down to the tiniest vibrations of the air. That, in essence, is what WaveNet achieves. It's a deep neural network that can generate raw audio waveforms, speech, music, you name it, from scratch. Now, picture this. A bustling city of sound, a vast metropolis where each building represents a single audio sample. WaveNet is like a master architect in this city, predicting what each new building, or sample, should look like based on all the buildings that came before it. This is what they call autoregressive. The model's predictions are conditioned on its own past outputs. But here's where it gets interesting. This city of sound is huge. We're talking tens of thousands of samples per second. How can WaveNet possibly keep track of everything? That's where dilated causal convolutions come in. Think of it like this. Imagine you're trying to understand a massive forest. You could try to examine every single leaf, one by one. Or, you could use a drone to get a wider view, skipping over some of the details to see the bigger patterns. That's dilation. It allows WaveNet to efficiently process long stretches of audio, capturing those crucial long-range dependencies. And what does this all add up to? State-of-the-art text-to-speech synthesis. That's what. In the paper, the authors show that human listeners rated WaveNet as significantly more natural-sounding than the best existing systems, for both English and Mandarin. That's like going from a robotic monotone to a voice that actually, well, breathes. Now, you might be wondering, can WaveNet do impressions? The answer, surprisingly, is yes. By conditioning the model on the speaker's identity, a single WaveNet can learn to generate different voices with remarkable fidelity. It's like having a chameleon of sound at your fingertips. Precisely, and the authors didn't stop there. They showed that this transformer architecture generalizes well to other tasks, like phoneme recognition. That's where the model tries to understand the basic sounds that make up a language. Fine, yeah, I guess. Look, the point is, this paper is a big deal. So, to recap, WaveNet is a deep neural network that generates raw audio waveforms in an autoregressive manner, using dilated causal convolutions to efficiently capture long-range dependencies. It achieves state-of-the-art results in text-to-speech synthesis, speaker modeling, and even music generation. Now, I want you to join me in visualizing something remarkable. Imagine you're standing at the edge of a vast, shimmering ocean of sound. Each ripple and wave represents a single audio sample, and WaveNet is the force that shapes and orchestrates this entire sonic landscape. What do you see? What patterns emerge as you observe this landscape? This is precisely what the researchers uncovered when they let WaveNet loose on the world of audio. What does it all mean? Well, it suggests that we're on the cusp of a new era in audio generation, where machines can create sounds that are not only realistic, but also expressive and even beautiful. Imagine a future where we can generate personalized soundtracks for our lives, create entirely new musical genres, or even communicate with machines in voices that feel truly human. The questions about the future of audio are absolutely captivating. And that, my friends, is why this paper is so important. It's a glimpse into a future where the possibilities of sound are limited only by our imaginations. So, go forth, explore, and keep listening. And who knows, maybe one day you'll be the one making waves in the world of audio. I'm Ernis, and this has been PaperLedge, bringing academic research to life, one paper at a time. Until next time, keep those ears open.